the triple integral of some function, oops, that's supposed to be x. The triple integral over the region E of the function of three variables with respect to volume is, well, let me get to this. This is nice. You're integrating the function dz, dy, dx. That's the order, right? But look at your limits of integration, right? They're function, well, except for this. This is constants, functions, functions, right? Do you think you can change the order of integration? No. No, you can't. You have to do it this way. All right, this ought to be fun. Evaluate the triple integral of what function? Y. That's it. The function of three variables up here is just the y function. Nice and clean and easy. dv, where E is bounded by these planes. So we've got to figure out what E looks like first, right? So let's try and draw E. And I've got to try and draw this in three-dimensional space. X, Y, Z. What is x equals 0? X equals 0 is the YZ plane. It's the ground, right? I'll just draw it out here first. There's the ground, right? Hold on. I drew the wrong one first. X is 0, YZ plane, back wall here, yeah? Then Y is 0, XZ plane, which is this wall over here. Kind of closing off the first octant here, aren't I? And then Z equals 0, which is the ground. And then the plane 2x plus 2y plus z equals 4. How should I draw that here? What would be the easiest way to draw that plane? Solve for z, like just move everything around and solve for z? We could do that. Yeah, I like that idea, but we can also, how many points do you need to define a plane? 3 points, right? So just let's find, how about where the plane hits the axes? So where does this plane hit the x-axis? How would you determine that? You set y and z equal to 0, right? So go into this plane, set y and z to 0, and you get 2x is 4. So x must be 2. So I know that one of the points on my plane, which I'm out of colors, so I'll just do it in black, is 2 on the x-axis. How about where it hits the y-axis? Set x and z to 0, right? And get y is 2 also. And finally, to figure out where it hits the z-axis, let x and y be 0, and you get z is 4, which is up here. I have a plane that goes through those 3 points. So what I'll do is I'll connect the 3 points together like this. Do y'all see the solid? Do y'all see that solid? That's E. Does the shadow of E on the ground look like a type 1 region? So let me now look at the XY plane, the shadow on the ground. I hit here at 2, right? Was 1 point. That's this one right here. The origin is this back point, so that's there. And then 2 here. So wouldn't that be the ground? Wouldn't that be this piece right here? Yeah? Now I've turned it so we can orient things the way we're used to seeing them, is that a type 1 region from double integrals? Yes? Yeah, because if we drew, the way we did is we said if we drew an arrow from here to here, and as long as the one on top and the bottom stayed the same as we move from left to right, then it is. But I actually need to know what that is, don't I? Don't I need to know what this function is? This function here is my g sub 2 of x, and then the bottom one is my g sub 1 of x. Do you all follow that? What is g sub 2 of x? Negative x plus 2. How'd you get that? You just looked at it, right? I mean, this is a line, right? Y-intercept of 2, slope of negative 1. The other way you could do that, though, that's the way I would do it. But keep in mind, the other way that you're doing that, or can do that, is that line is this right here, right? And that's where that plane hits the xy plane, right? When you hit the xy plane, z is 0. So if you go back up to this plane and you let z be 0, you get 2x plus 2y equals 4. If you solve that for y, you will get this right here. Understand that? I only say that because if it wasn't as simple as a line, then that's what we would have to do. Questions? Okay, yeah, so if I have to first understand that this line right here is this line, right? And this line is where that plane hits the xy plane. Anytime you hit the xy plane, z is 0, right? So if I take this right here and I let z be 0, let that z be 0, it's not there, and I solve this for y, you see it? You would get the linear equation which represents that. Okay? All right. Can you tell me what the restrictions on x are here? 0 to 2? So here's what I got so far. I've got x is between 0 and 2. I've got that my y is between, what? 0, right? This function here is a flat horizontal line. And then the one up here, negative x plus 2. So this is going to go from 0 to negative x plus 2. The last thing we need to figure out is what our restrictions on z are. And this is where we have to look back to the 3D picture, and we have to figure out what's the top surface, what's the bottom surface. So, Bessie, what is the top surface for this region E? It's the plane, isn't it? The plane. This triangle basically is the top of the solid. So how am I going to write that plane as a function of x and y? Solve for z. So take this right here. Now I'm going to draw it. This arrow is representing this surface right here. That is z equals 4 minus 2x minus 2y. Do you agree with that? Now, in terms of the formulas that I just gave you, or from the notes, I know it's hard to see. Our y's, I said, were restricted between g1 and g2. That's why I wrote g1 and g2 here. Our z is restricted between u1 of xy and u2 of xy. So this one is actually u1 or u2? u2, because it's the one on top. So this, I'm going to replace the z here. I'm going to say this is u2 of xy is that top surface, which is the plane. And then what is the bottom surface? What's the bottom of that? It's just the xy axis. I mean, xy plane, isn't it? The equation of the xy plane is z equals 0. But that's my u1 function. So u1 of xy equals 0. Understand? And so I can come back over here now and I can say z has to be between 0 and 4 minus 2x minus 2y. How are we feeling about that? All right, so we got to set it up now, right? I need to erase, so I'll give you about 4 more seconds. All right. So I've got to do a triple integral. My limits on x were 0 to 2. My limits on y were 0 to negative x plus 2. My limits on z were 0 to 4 minus 2x minus 2y. Right? What function am I integrating? Y. With respect to z, y, and x. That's it. That's the setup. And now we do the integration. So I'll do the integral now. Do this one. The antiderivative of y with respect to z is yz, right? I said yz, I wrote xz. And then from where? Z equals 0 to z equals 4 minus 2x minus 2y, right? That's what I've got to do. And then I still will need to do dy dx after I'm done. So replace z with this, and then we replace z with 0. Thank goodness for the 0, right? I don't have to worry about that. So just z right here. So we will have equals integral 0 to 2, integral 0 to negative x plus 2, and then what happens if I replace z with that and distribute the y? What do I get? Over y is 2xy minus 2y squared. Yeah? dy dx. And now that is basically what we did a couple of classes ago, right? Should I dot dot, or you want me to go all the way? I don't care. It's up to you. So let's take a vote. All the way? One more? What would be the next step? Do what? Yes, dy. So I would need to integrate this, right? I'm going to do this one right here. So if I take the antiderivative of that with respect to y, I get 2y squared minus xy squared minus 2/3 y cubed. Everyone agree? Yeah? Anyone disagree? We're good? Evaluating where to where? Y equals 0 to y equals negative x plus 2. Right? That's my middle integral now, right? So I have like an inner, a middle, and an outer integral. And then you go in and you replace your y's with this. And then you place your y's with 0. Good, that's nice news. And then you're going to have a huge like polynomial in x, aren't you? And then you just integrate term by term, clean it up, and good to go. Does that qualify as one step, or do you want the negative x plus 2 in there?
No, it's long.
Yeah. But you're good then? Okay. All right. Easy does it. What do y'all, how do y'all feel about this? Do y'all feel like, I don't know. I was thinking about my Cal 2 class the other day, and like, we're in there, we're like laughing and having a good time, and we're all like, everyone's, and then I come in here and like everyone's so quiet and so, I don't know. Is it miserable? You're just miserable? Okay. I can appreciate misery. All right. All right, so what would happen if I have a solid E, I want to integrate over this solid E, and I look at the shadow on the ground, and it's not a type 1. It's a type 2 from a double integral. Well, the only thing that's going to change is that now your y's are stuck between two constants, right? Y's are stuck between two constants. Your x's are stuck between two functions of y, and your function, right, your solid is still stuck between two functions of x and y. So the only difference in the actual integral is that it's like your x's and y's are going to switch places. Your y's are going to be the outer integral, and then the middle integral will be the x, right? And then your inside integral will still be the z. So in terms of the setup, here it is. So you see that order of integration would change? Only the last two switch. Triple integral xz dv is the integral, where E is the solid tetrahedron with these vertices. I think I should be able to draw that pretty easily. Let's see. X, Y, Z. Okay, the origin is one of the points. Nice. 0, 1, 0 is this point. 1, 1, 0. 1, 1, 0 here. That's on the ground. And then 0, 1, 1. 0, 1, 1. Do y'all see it? Connect them. I'm going to connect some things together here. This point with this point, 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 this point with this point. Do y'all see that thing? I think I have a right angle right here. Do y'all agree? I have a little right angle there. I don't know, for some reason I don't like that drawing, but do y'all see it or not? Yeah? Okay. So that's my solid E. And if I look at its shadow onto the ground, there really is no shadow because it's on the ground. But let's not get like that, okay? You understand what I'm saying, right? Its projection onto the ground is going to be what? Let's see. That base, right? Good. So it's touching at the origin. It's touching at y1, which is this point. It's touching at this point, which was 1, 1, which was out here. And so it looks like this. That right there corresponds to that on the ground. Is that shadow or projection onto the ground a type 1 or a type 2? Or both? It's both. It's either one, right? It's your choice. See, if I draw a vertical, right, like this, and imagine moving this left and right, the top and the bottom curves are always the same. So it's a type 1. But if I draw it the other way,